Welcome to Radicals and Exponents. Our objectives for this lesson are to apply your understanding of properties of exponents and radicals to simplify some expressions that have rational exponents. Think about this property that you already know. For integer exponents, m and n, you know that a raised to the m and then raised again to the power of n is the same thing as multiplying the exponents, a raised to the m times n. We're going to use that property, in fact we're going to extend it, to work with some fractional exponents below. Let's look at the first example. We want to go ahead and write each of these expressions in standard number form without exponents or radicals. So how can we simplify this? Well, using this property, don't be afraid that there's a fraction here. We still apply the property. We are taking the power of 1/2 and we're raising it to 2. So in other words, we have two of these expressions. 5 to the 1/2 times 5 to the 1/2. Well, we know then that what we need to do is take 1/2 times 2. 1/2 times 2 is the same thing as 1/2 times 2 over 1. 2 times 1 is 2, and 2 times 1 is 2. 2 divided by 2 just gives us 1. And anything to the 1 power is just itself. So essentially what we have is 5 raised to the 2 over 2 power, which is just 5 raised to the first power, which is then just 5. Look at this second one. Pause the video for a second and see if you can compare the second one to the first one. Well, notice again we have a power of 1/2 raised to 2. We know that we just need to multiply these two together, and again we will get 1. So this one's pretty easy to just say, well, that'll still be 2.4. But what about the third one? Now we have a quotient, 9 divided by 4. But if you remember your properties of exponents, we take the power and we apply it to each number, to the numerator and then to the denominator. So we could rewrite this as 9 raised to the 1/2 power over 4 raised to the 1/2 power. Think about your previous lessons and what these fractional exponents mean. This means what times what is 9. I need two things that are exactly the same that when multiplied will give me 9. In other words, I could write this as the square root of 9. Same thing with the denominator. What two things when multiplied, two of the exact same number I should say, when multiplied will give me 4? Well, in order to find that, I could just take the square root of 4. 4 to the 1/2 is the same thing as the square root of 4. Now I can simplify that. The square root of 9 is 3 and the square root of 4 is 2. Let's look at our final example. We're combining multiple properties here. We have a product in here and a product in here. We have power raised to powers. We've got a lot going on. So let's see what we can do. Well, the first thing is this 1/2. Just like the previous problem, we need to apply this power to every term in the numerator and every term in the denominator. So let's try that. We would end up with 4 to the 1/2 power times x to the 1/2 power, all divided by 9, also to the 1/2 power. But then look what happens here. We have y to the 1/2 power. So what do we do with that? Well, remember our rule. We need to multiply these. 1/2 times 1/2 is 1/4. Let's simplify this as much as we can. Well, we now know that 4 to the 1/2 power, as we found out down here, is the same thing as taking the square root of 4. The square root is what times what is 4. Well, we can simplify that into 2. We can't simplify our x term because we don't know what that number is, so we leave that to the 1/2 power. Below here, what is 9 to the 1/2 power? Well, we figured it out in the previous problem. It's the same thing as the square root of 9, which is just 3. But then we would need to leave the y to the 1/4 power. This is one way to write this, but it's not the only way to write it. Let's write it in equivalent form. In this problem here, we obviously are not able to write it without exponents or radicals. Well, since we're writing it with exponents, let's now write it with a radical. So how can we change this to write it as a radical? Well, 2 is simplified. What is x to the 1/2? Well, that's the same thing as the square root of x. Remember that 2 is our root. What root are we taking? We're taking the squared root. On the bottom, we have 3, and then we have y to the 1/4 power. So what root are we taking of y? We are taking the 4th root, so we need to indicate that by putting a little tiny 4 above our radical. This means this is the 1/4 root of y. So in other words, we're looking for a number eventually that if we multiply it by itself 4 times, we would get y. Now you've seen multiple equivalent ways to write these different expressions. Let's move on. Let's look at some radicals now. This is just a review, but we want to practice rewriting these expressions in an equivalent form as well. So how can we rewrite the square root of 3 times b? Well, we can rewrite that as the square root of 3 times the square root of b. Sometimes that's helpful if we need to separate things inside the radical. We can't do anything else beyond that. How about number 2? Well, we have a fraction all inside a radical. We can rewrite that as the square root of 18 over the square root of 25. Here you can see why this is helpful, because in this case, we can take the square root of 25. That's equal to 5. So now we can rewrite this problem as the square root of 18 over 5. 5 is no longer inside the radical. But let's look at 18. You've been practicing simplifying radicals, so how can we simplify this? Well, one way, remember, is to write all this out, to factor it out. Well, 18 is the square root of 2 times 9. And 9 is really 3 times 3. I could have just left it as 9 because I know what the square root is, but I wanted you to see all the prime factorizations. In this case, because we're taking the square root, we're looking for pairs. We're looking for buddies. And here we have a pair here, 3 times 3. The square root of 3 times 3, what is that? Well, we can rewrite this as the square root of 2 times the square root of 3 squared, because we have 2 3's, all over 5. Now it's kind of obvious. The square root of 3 squared is just 3. So now we can pull the 3 out, and we're left with the square root of 2, all over 5. You can see how if we use the properties that we know, it can help us to simplify expressions like these. How about this last one? Well, this is all spread out. Can we combine this together? Since they're all multiplication, we can. We can combine these a's into a, the square root of a times a times a. And then we can combine the b's into the square root of b times b. This is one equivalent way to write it. What's another way? Maybe by now you can see that we have 3 a's. That's the same thing as a cubed. And we have 2 b's, which is the same thing as b squared. But we still have 2 expressions here. Since it's multiplication, we could combine these together as a cubed times b squared. So what we've done is we've taken something that's been expanded and we've put it together. Now if we actually did want to take the square root of this, well, right now we can see that b squared is a pair. That can come out as b. We can now take the a that's cubed and we can separate that back out too. We can rewrite it as a squared times a to the 1, or just a. So look at how we're manipulating these variables to get what we want. A squared is a pair. We can take that outside now too. So now we have a times b on the outside of the square root, and what's left? Just a. And that concludes our lesson today with radicals and exponents. You should be a little more comfortable applying your understanding of properties of exponents and radicals in order to simplify expressions with rational exponents.